All right, students, shall we start? Can anyone please confirm if my screen is visible? All right, cool. Okay. So students, today we all are gathered. Thank you so much, sir. Summer's father gave me a thumbs up. Thank you so much. Thank you so much, everyone. So students, today we have gathered because we have the youngest data scientist of all, Siddharth, with us among us. My voice is breaking. Is it breaking for everyone?
No, Samreen ma'am, it's clear.
All right, cool. So as I was mentioning that we all have gathered over here today because we have the youngest data scientist, Siddharth, among us. Now, before he gave his introduction and he help us to understand about a concept that is face mark detector, let's just quickly talk about Clever, the organization with which we all have been gathered, right? That has, our family Clever, okay? So Clever is empowering the young learners with artificial intelligence and data science. And as today, all the students of Clever are joined together. Some of them are in the higher levels or lower levels or just started the journey with us, and we all welcome you. Okay. Now, what are we learning in Clever? These are the 4 domains on which we all are focusing. That is, first of all, we all learn Python programming language or the block-based programming, that is Scratch, based on which level the students are in and based on their age group as well. Plus, whenever we learn coding, we do learn some of the concept of maths, right? Like when we want to calculate distance between 2 points, or we want to calculate the square root or maybe square, and so on and so forth, right? Many mathematical concepts like probability and everything do come into the picture. Then, because the course is focusing around artificial intelligence and data science, that's why AI can be comprised of 2 concepts, that is the programming and machine learning concept. Plus, data science also has the analytics part, like if we have the data in Excel sheet, how can we visualize it, like make graphs, isn't it? Or maybe without opening the Excel sheet, we need to understand that how many rows and columns we have, whether we have some missing values or not, and so on and so forth. So basically, whenever a student enrolls with us in the data science, junior data science program, then these are the 4 domains on which we primarily focus. So Clever offers tailored coding and artificial intelligence program for kids and teenagers from ages 8 to 16. We have launched our first junior data scientist program where we prepare teams to be ready for the digital world with artificial intelligence and data science. How? Because every student gets to make various projects, right, on various topics that we have that have been included in the domain of machine learning and artificial intelligence. Now, why exactly a student wants to come get associated with Clever? Because our curriculum or the content that we are using on our platform AI Labs is developed by the professors from MIT. Every student has, whenever they participate in the workshop that are being conducted by us, they get a global certification by Google, IBM, and Microsoft. Then the students get the internship opportunity with a professor from University of Oxford and under the column of AIIT. And the project that we have, AI Labs, no matter if a student is even not continuing with us or has taken a break, will be having a 6 months of access for all the curriculum, all the content and the code where they can practice and acquire the new skills of artificial intelligence. Now, Clever has been covered in media from so many, like from last 2 years, we have been covered by media like the Khaleej Times, which is a prominent newspaper in Dubai. There, a 6 years old or 7 years old Sanvi was there who was covered, right? She was the first one to complete, she was the youngest to complete our internship program. Plus, in the business world, Clever was also featured with under the column of that we have launched our Asia's first junior data science program, and so on and so forth. So that was all about Clever that I wanted to talk about. today's webinar is more focused around Siddharth, who's the youngest junior data scientist. And now, Siddharth, I would like you to just turn your webcam on and continue with this webinar. Siddharth, you can please unmute yourself.
All right, yes. Thank you, Samarina. So, hello everyone. My name is Siddharth Pilli. I'm Asia's and world's youngest data scientist right now, and I'm here to share my journey on my data science journey, my AI, my machine learning, or my tech journey, and also help you guys to build your very own face mask detector. So, I'll just get started. I'll just share my presentation with you all. Yeah. So, all right, everyone. So, welcome to the Clever Masterclass by Siddharth Pilli, by me. And today we'll be building a mask detector. So, basically, a web application which can help you, detect if you're wearing a mask or not. So, it's basically a very simple classification program. So today's masterclass, I wanted to have it divided into two sessions. One regarding I'll explain my journey on how I came across data science, how I came across machine learning and artificial intelligence, and also the second part where I also help you guys develop your very own mask detector, which through different types of libraries like Streamlit, Python, TensorFlow, OpenCV, and Keras. So I'll first tell a bit about myself. So I'm Siddharth Pilli, like you know, I'm the world's youngest data scientist. I'm currently working at Infinity Learn. It's an edtech company. I'm also very passionate about deep learning, computer vision, and machine learning as well, because I totally understand with the amount of exponential growth on how data science and machine learning, products are being taken over right now, whether it be huge tech companies like Google, Netflix, Facebook, who are trying to implement AI and machine learning into their softwares to give the users a much more personalized experience, or even simple startups who want to solve very base root level problems using these amazing technologies. All these types of deep learning and computer vision technologies are being used everywhere. I'm also providing training on Python and data science for students and professionals. So until now, I've provided data science and Python trainings for students across the world, and also have provided given some professional advice, help different types of working professionals to get them a right internship and right programs as well. I've given talks for many esteemed schools, universities, and colleges across India, mainly on motivation, on data science, and how AI is going to help our future. And I'm also currently working at IIT Hyderabad as a deep learning computer vision intern under Professor Vineet and Balasubramanian, who is the head of AI department in IIT Hyderabad. So that's basically a bit about myself. So in today's session, I at least want to get you guys a small perspective on why I wanted to. Or I'll just try to have it into one point. Actually, a few more points actually. One being why I wanted to get into a field of data science and what it took me to get into the field of AI, machine learning, and everything. And and what is the potential, because we see data science, AI, ML every day in the newspaper. Like, what actually is the potential for data science, machine learning, or AI in the current developing present or the next future out there? So to explain my journey, I want to divide it into 3 points: curiosity, persistence, and practice. These three are the necessary building blocks. To be honest, this is the foundational base which you need when you want to learn anything. For my case, when I wanted to learn data science or machine learning, these three were the pillars for my success. So, for me, starting, Now I wasn't again, I don't even have high IQ. I'm just an average student. But wow, but what exactly gave me the spark to, start creating these applications, to start becoming a data scientist? Well, it all starts for me with curiosity. I believe curiosity is a vital role to any field out there, to any hobby as well. The knowing of, you want to try to learn more, try to understand the question, try to explore the world out there, and all these fields and everything. That's something which you really need when you want to, like learn a new field, learn a new hobby, or even learn something like data science. For me, the curiosity of, I play games every day. I play a lot of games like Roblox, Fortnite, and Subway Surfers as well. When you use these types of applications, or when you're experimenting with these applications, you're playing these games, you have that small spark inside you, the small curiosity on you want to know how exactly is this app, or how exactly is this game was developed. And that small curiosity can give you big rewards, and that's really what we call, the butterfly effect, on how a simple change can occur into, such a big revolution out there. And for me, that simple curiosity on trying to experiment with these apps, trying to use these apps and etc., that small spark and curiosity was what I needed to to start with this whole data science and everything. So as you go, you have a simple 7-year-old who started, who has this curiosity of wanting to build applications, on understanding how these applications were created and everything. So that's cool from there. But what made me, so then why exactly did I go to data science? Well, I'll just come to that a bit. So my first programming language which I ever started was with Java. I wanted to learn Java because from what I saw, many applications and many hardware, software tools which I use every day was developed by Java. So I saw a huge potential there. And that's where I wanted to learn Java as well. And another reason what made me start learning a programming language like Java was the second point out there, exploring the inventions and the new minds who are accomplishing them. In the whole point of like 2011 and 2012, Java has literally dominated over the development field. You have many young entrepreneurs, or these young, problem solvers who are coming into the field and trying to create these new, useful, and these amazing inventions, which are, trying to say, trying to make our life better, and trying to give us a much more happier, better, and solution-free life to work with. And that's where the second point comes across, that you have to always explore these different types of inventions. So let's say if you're really passionate about data science and machine learning, you have to try going to different types of research papers, try to see different types of articles on what exactly are the new algorithms, what exactly are the new inventions being taken across in the field. So this is the second point to remember. For me, when I started to read all these different types of articles, seeing videos of these visionaries who are building these inventions and trying to, having them established as these new minds who are changing the world, that part has really inspired me to start learning programming languages. So that's where I started learning Java. In a few months, I got a good hand over Java. Developed a very few base root of applications as well. It's not very high tech, but it's a small start as well for something big to come. So that's where I started learning Java. From Java, then I moved on with Python. The reason I really wanted to move with Python is that I saw a huge potential with Python as well. Now, if you see, the whole concept of Python was to develop an effective and a very simple programming language that can be in two things. One, be a purposeful programming language, which means it can be used for developing games, web applications, and to also try to be a very high tech programming language as well, where it's simple yet it's very efficient to work with, where a Python programming language, which can be used for building a snake game, can also be used for launching the entire NASA, be a rocket, or even it's a rocket, or trying to solve the biggest problems right now. So that's where I saw this huge potential with Python, where it's simple, but it has, but it has higher solutions affordability. So that's where I wanted to learn Python. So yeah, and that's basically where I wanted to explore other programming languages as well. And when I started to learn Python more and more, trying to develop all these applications, I stapled Python as my preliminary language, which I wanted to work with. Mainly, it's easy, which means anyone out there, you bring in a kid who's like 7 years old, 6 year old, or even you guys, or who has no understanding on how exactly coding works and all this. You don't even how code works. But when you bring someone who doesn't know coding and you ask them to read Python code, it's literally like reading English. So that's the reason why I love working with Python, and even now it still remains as my favorite programming language. So I came until Python. The third point which I wanted to go across is get an inspiration from the tech industry. When you want to do something big, or when you want to learn something, and you have a certain hunger in you, you really need an inspiration from the industry which you're revolving against. Because you want to have you have to always have a person which you look up to. Let's say you're maybe into something like you want to be an entrepreneur. You want to look at like these shoes mice, like maybe Ratan Tata, or maybe Zuckerberg, or etc etc. So when you take an inspiration from them, that's basically what you define yourself as. I want to be as huge as them. I basically want to be as problem solvers as them. So you always need a good inspiration from the industry which you're working to. And now my favorite part, get and competition. For me, I always love competition. Trust me or not, I think competition is this one part where you can understand how exactly your peers are working right now, and based on that, you can try improving your strengths, try to improve your weaknesses as well. So when you try to get a competition, you know what you're working towards, you know what you want to do, because you want definitely be ahead of your competition. So you always need to get yourself the right competition. This can be me, this can be, let's say, someone like Tanay Bakshi, there's like Nickel, and there's almost like n number of competitions. But you have to always get yourself the right competition to, let's say, maybe, to at least have a sort of challenge saying, so this is the person which I want to go ahead. So try always getting a good competition. For me, my competition was always, I mean, this might be funny, but Bakshi, although he's a really cool guy, and there's a lot to learn from him as well. She was a pretty big competition for me, because trying to see him write all these cool research papers, all these blog posts and everything, that made me kind of come into a competition part. So the Bakshi for me was a competition, and he still is. And I think he's always doing these cool research things as well. And this is the second last point. Learn everything as a beginner, but solve problems as an expert. Now, I love this point a lot, because now, even for me, if I wanted to go into something new, let's say I wanted to start learning JavaScript right now, you should never have that overconfidence saying, I'll just start because I already know Python, JavaScript is easy, so I can just ace JavaScript in like seconds. No, you have to learn everything as you're a beginner, even though you might be the best in the field of maybe something like Python. But when you're starting with something new, which is something which you never worked with, you have to always start as a beginner. When you start as a beginner, you start finding that curiosity, and that's where you can start solving. When you start solving problems, you understand, okay, so there's the mistake I made, and that's how I can correct it. So remember, when you learn something new, let it be a programming language, maybe an algorithm, always start as a beginner. But when you're trying to solve the problems, try to make it seem that you actually know what you're doing. You understand the problem case statement, so you can solve it in a much more better way. And finally, gather a helpful network. Clever is actually offering great services right now, I have to say, because when you actually get a learning opportunity at Clever, because you're getting a good access to a network like Oxford, MIT, and etc. And this is where you can get good internships and etc. as well. So another thing which you have to remember is always gather yourself a very helpful network, which is going to help you to learn more and to get more learning opportunities as well. And that's basically what I want to get off with curiosity. And that definitely played a huge role in my career and my learning life as well. And my second point, persistence. And trust me, persistence is something which is really important. Persistence, why is it important? Because trust me, you learn Python, you get better at it. And you can't just leave it. When you're really good at something, you have to always try solving these new challenges, try coming up with new problems, and try solving it each and every day. That's where you can learn more about maybe more about the problem solving skills, learn more about the Python language. Once you lose this persistence, you can't really go forward. You have to always have this certain routine which you have to follow to make yourself to the extreme. Now, if you guys have ever played, let's say, the Spider-Man games, I guess there's just previously Insomnia Games has made Spider-Man 1 for Peter Parker, and now they have previously made the second a Spider-Man game, which is Miles Morales. And I really love this quote in that game saying, be better than yourself. So I always believe this, that you should not be yourself, but you have to always better yourself. And how do you better yourself? To that persistence. So that's really important. And finally, practice. Try practicing every second. Try practicing as much as you can. And I always believe, because sure, you may know how you can solve a problem and everything, but that really comes to a case when you just practice it on and on and on. For example, you want to learn machine learning, data science, you have a good curriculum, but it's only going to work unless you practice again and again. Try to practice to write the algorithms without maybe a TensorFlow package. That's a good challenge. Try to practice to build your own research papers, and try to practice to do all this data engineering, pre-processing stuff. So this um, I think we have some. Oh, never mind. So yeah, so these are the three founding pillars to what I would say really helps my journey and what I am right now. And now I want to get into the concept of why data science, machine learning, and artificial intelligence. So you have understood that about my success, my journey. But why exactly did I choose data science, machine learning, and artificial intelligence? And why I want you guys to start pioneering concepts like data science, machine learning, and artificial intelligence at this point. My first point, from past few years, we have seen an exponential growth in data. Now, if you see from 2010, 2012, we have many people who started using Facebook, then be Twitter. We have seen many people playing different types of games and etc. etc. And when you perform all these types of cool activities out there, this is where data is actually coming through. When you, let's say, post a Facebook comment, that's data. When you post a Twitter, let's say some Twitter post, that's data. Or even, let's say, when you try to maybe play Fortnite, and when you're chatting with your friends as well to watch that, that's data as well. And in these years, as for example, if the technology of hardware like laptops grow and grow and grow, the number of, let's say, the number of data is going to grow as well. And in this decade as well, we have seen a humongous rise in the whole concepts of data until now. And that's the reason why many people have saw a huge potential for data science, machine learning, and artificial intelligence. Because what is data science? Okay, let's forget on ML now, but what is data science? Data science is where we're trying to understand maybe different types of insights, maybe trying, we're understanding this insights by, applying these cool scientific operations out there. That's really data science. And how can we apply these cool scientific operations? If we have data, and because we have seen this huge growth in data, that's why data science has a good potential in the world right now. Second point, this is the time industry is moving forward. So many companies need a good expertise who are skilled with artificial intelligence, ML, or data science as well. Because we have this huge amount of data right now, so companies are also looking forward to for data scientists. Why? Because they want people to make good decisions based on data. Maybe they want people who can try creating these cool models, these cool algorithms, which can help to make the user's experience more personalized. Or they also want to make maybe a certain models or some type of softwares out there, which can again might correlate to machine learning or artificial intelligence. Do you guys need some few examples where ML and AI is being used? Well, does any? I think most of you might have used Prime Video, Netflix, or all these OTT softwares at some point of your life, right? Right, everyone? Yes, so when we actually use these Prime Video, Netflix, or some OTT platform, these OTT platforms tend to track what movies you're watching, what series which you're watching, and based on this data, they can try understanding what series which you might like or what movies which you might like as well. So this is just one example. If you see another example, we have Amazon where Amazon tries to track your search activity to, let's say, at least give you ads on, let's say, maybe you've been looking for sorry, maybe in Google we have been searching a lot for Bose headphones or something like Bose headphones and etc. etc. So then Amazon understands the search pattern and tries to recommend you, hey, do you need some Bose headphones or do you need some Bose headphones? So that's in the use case where AI is being used right now. So the industry is going to need many more people with artificial intelligence. Third reason, now I'll now trust me on this. AI became the most easiest concept to implement right now because we have different types of libraries like TensorFlow, Keras, PyTorch, and these all are these cool libraries which are trying to all these cool libraries which tend to create an AI or trying to create maybe something like a machine learning algorithm. These libraries made it very more easy, which means anyone out there can easily implement a machine learning algorithm. And finally, the fourth point on why you guys like, all the kids out there, all the below 18s, I think you guys have the best mindset. I think we as students or we as pioneer kids, we have the best mindset to ask questions because we are still a developing mind. So, for example, when we see a sun, we always want to understand like why sun why sun is like so far away. Why is water very translucent or maybe how exactly we can see the world, how is our eyes understanding that. This is an age where we have all these different types of questions coming and we have this like pure curiosity which is coming to us. And when we have this curiosity which is coming to us, we tend to ask everyone out there some questions. We try to think outside of the box instead of a way too practical approach, which means we don't think of this practical world, but we think through curiosity. We only ask questions. And that's a skill a data science 100% requires. He has to always try to think outside the box. Instead of going to this practical approach, instead of the curriculum approach, we have to think outside the box, and we already do. And that's really what's needed when we want to become a good data scientist, a good AI, or a machine learning engineer. So this is why I choose data science, machine learning, and artificial intelligence, and why I also think you guys this can be a great choice for you guys to master in as well. So that's basically about my journey and about data science, machine learning, artificial intelligence, and on why I choose it and why I think it can benefit you guys as well. And finally, about the project. So now I'll finally explain about what exactly is the project which you're building in this masterclass. So in today's session, guys, we'll be building a very own face mask detector. So unfortunately, I don't have my face mask around, so we'll just take some sample images out there. So end of today, we'll be building our very own face mask detector using a deep learning network. So again, a deep learning network is so in artificial intelligence, we have a field called deep learning. So deep learning it basically just mimics our brain, our neurons, and everything to create this mathematical algorithm. So finally, this application is going to detect if a person is wearing mask or not. So for example, if you're wearing a mask, this application is going to say, hey, this person is wearing a mask. If you're not wearing a mask, this application is going to say, this person is not wearing a mask. So it's a very simple classification problem. So for this problem, we'll be using a neural net. We'll be using a neural network called MobileNet V2. So there's basically a neural network available called MobileNet V2, and this is a very good neural network because one, it's very efficient to work with, and second, it has this. It doesn't take too much on the GPU as well. So it's not too much. It does not take too much on the hardware as well. We'll be using MobileNet V2 and we'll be using this new technique called transfer learning to develop this application. So I'll try explaining transfer learning as we go ahead and develop this. And what are the different types of libraries which we'll be using for this application? Well, we'll be using TensorFlow, Keras, OpenCV, and Streamlit to develop this application. So this is a small outline on what exactly is the application, what modules which we'll be using, and which algorithm which we have chosen to develop this project. So I'll just explain the entire process out there. So fine, the first part comes to the training. Now remember guys, when we want to, let's say, implement a machine learning algorithm, we need to first start off with data. So I basically found this amazing data set from, I believe, Prajnava. I'm so sorry if I'm pronouncing the name wrong. I'll try including it in the GitHub as well. But yeah, so I basically got this data from GitHub from Prajnava. So the first part is let's collect data of people with mask, and I mean basically images with mask and without mask from a data source. This can be GitHub or Kaggle. And the second point now comes to pre-process our data for model preferences and maybe even add some augmentation. So now machine learning works in a way so it's not completely black box, which means there is a bit of tuning which you have to do before you start training the machine learning model out there. So you have to do just a bit of adjustments, like maybe images height. You have to you have to have all the images to be in a certain height and a certain width as well. So you have to do something like that. And you have to also have these different types of colors and etc etc. So that's where you have to do a bit of pre-processing for our machine learning model. And the third part is let's build our very own MobileNet v2 architecture with ImageNet weights. So there's actually this wonderful technique called transfer learning. What transfer learning does is, like, without us, I mean, when we train our very own models, it takes a lot of time, right? Of course, right? It's going to at least take 2 or 3 hours for the entire machine learning algorithm to learn. And when we try to implement transfer learning, it tries to make that process faster, where it uses already available weights out there to train this machine learning network. So that's how we'll be using transfer learning. Fourth part, let's train our model with the data training. And finally, save the model as H5, we can use it in our web application. And now for detection, what do we use for detection? We first load our model, predict the image, extract the region of interest. So region of interest is supposed to mean how exactly, like, which part of the face is the mask being detected. So we extract the region of interest from the image, and we finally predict if the person is wearing mask or not with accuracy and also a B box. B box is basically the square region of where our prediction is being happening. So that's basically the detection process and the training process. Hopefully, did everyone understand that? All right, then, great. So that's basically the detection process. So with that, let's start, develop our very own application. So first things first, I'll just show you guys on. Now again, we're not going to do like a live actually recording through it. So I already have an entire IPYNB notebook ready. So an IPython notebook. So we'll be using that IPython notebook to see how exactly the machine learning, how exactly we're getting the data and how we're training the machine learning model as well. So I'll just share my screen here. Just give me a second. Just give me a second. Let me know once my screen is visible, everyone, okay? All right, I guess this works out then. I'll just share my screen. Just give me a second. Yeah, there we go. All right, so I'll just have a new tab and stop working. Yeah, there we go. All right, so hopefully my screen is visible, right, everyone? Is it visible? Okay, great. So the first things first, let's import all the necessary libraries. So for now remember guys, training a machine learning a MobileNet v2 with data is going to at least take 2 hours. So I'm not going to show you the actual training part, but I'll help you understand what we're doing here. So first things first, we are importing NumPy. So NumPy is basically a Python package which can be used for performing array operations. So that's the first thing. And the second part, and also don't worry, I'll be sharing the code as well. I'll be sharing the entire code in GitHub. So if nothing to worry on that, you can try it on your own as well. The second part, we'll be importing pandas. Pandas is basically this data manipulation library for Python, where you can, let's say, import the data. You can try doing different types of engineering and manipulation techniques. Then we'll be importing OS just to get all the images. And now comes TensorFlow. So the first part, we'll just import TensorFlow as TF, and then we have different types of packages or the libraries inside TensorFlow. Now, remember in the starting when I set up all these pre-processing stuffs for images, right? For that reason, TensorFlow has this amazing module called Image Data Generator. This image data generator module sorry, automatically basically pre-process all the images for us. So that's a very hefty part I've taken. And then MobileNet V2 architecture. So we're importing the MobileNet V2 architecture. And then in TensorFlow, we'll import different types of layers like dense layer, flattened layer, average pooling 2D, remember the pooling 2D, finally dropout. So I'll try explaining each and every layer a bit more depthly in just few minutes. Then we'll be having an optimizer. So for now, we're using Atom. Just to keep it simple, we'll use Atom as our optimizer. And finally, model to, let's say, load or save our model. And finally, load model to, once everything is done, we can load the model. Matplotlib library. Matplotlib is mainly used for graphing. So when you want to create plots or graphs, you tend to use Matplotlib. And finally, CV2. CV2 is supposed to mean for OpenCV. OpenCV is how we can do, how we can capture our image, capture all these image techniques as well. So first things first, data pre-processing. So for data pre-processing, what I've done is first we provide the directory. So here I have two directories, my training data and my validation data. So I just provided the directories. It's in the same folder. So train and validation is enough. And now for all the hyperparameters. So hyperparameters, first things first, image size. Now MobileNet V2 architecture accepts an input size of 224 by 224 into 3 entries of this mean RGB channel. So this is the image size, which is 224 pixels into 224 pixels. And finally, initial learning rate. Now I always keep learning rate very low. So I think I so I equals number by 4, something which I seems pretty good. But if you want, you can keep your learning rate as 0.001. But remember, don't keep it too high, or else the entire model might convert. So always try to keep your learning rate low. So this is something which seems all right for me as a learning rate. And now epochs. So for now, you can just have 20 iterations for a machine learning model to learn. So that's why I kept 20 epochs. And finally, batch size. So batch size is basically the amount of batches you're having to size up. So try keeping that as 64. So this is basically all the hyperparameters. And now coming to pre-processing. In the first part here, we have is image data generator. What does image data generator does is we basically give it different types of parameters like rescale, sample wise. Again, this all is not really necessary. I'm just explaining that. But basically what this does is this generates all the images. Okay, we're just giving the values for it to generate images. And the train generator is where we give it out the size, patches, and all these different types of things. And as we can see, I kept something called class mode right here. The class mode is supposed to mean, like, when we try to do a classification problem, we need to mention how many classes we have. For us, we have two classes, one being with mask and without mask, which means, so that's two classes right there. So that's basically all the images being from the directory. And now data visualization. So right now I just had this simple program which it traced to three images and just selects few images from train data from with mask and without mask. So we can see three images with masks and three images without masks. And now coming to the interesting part, transfer learning for our mobile net V2 architecture. So first things first, we have to, obviously we have to bring in a mobile net V2 architecture here. So I just created a variable called MobileNet, and then we use the MobileNet V2 module. So like I said, the input shape is 224 into 224 pixels, And obviously this is a RGB image, so we have so we have the three channels out there. And finally, weights. So for transfer learning to work, we have to mention the weights here. So that's why I mentioned weights as ImageNet. And finally, we're including top as false. And for actually ImageNet to work, we basically get all the mobile net layers to be trainable as false. And now coming to the base layers of the model. So finally, pooling basically, sorry, pooling basically what it tries to do is it tries to it basically brings down the entire image into a certain size. So if you have 7 by 7, so that's maybe the prime. So it tries to bring down the image for that certain size out there. Then it basically flattens and then so these are a bit of complex concepts which I don't really think I can explain. But finally, I'll just come down to prediction. What really happens in prediction is we're providing the value 2. 2 is supposed to mean the number of classes. So how many classes do we have, everyone? Yes, which means we have 2 classes. And what are those classes? Those classes are with mask and without masks. We are providing an architect. We are providing our machine learning model saying there are two outcomes here. One can be without mask and one can be with mask. And then we're using an accuracy function called softmax. And what softmax really does is it tries to the softmax can be used for multi-classification and singular classification as well. But what softmax does is it tries to gets the sum of all the values out there and then tries to divide by a certain number to basically get all the values from 0 to 1. So the actual prediction is going to be from 0 to 1. That's really what softmax does. And then we initialized our output here, where our model is basically our machine learning model with the inputs as MobileNet input, which is 224 by 224 by 3, and the outputs is prediction, which means it's 2 layers with the activation function as softmax. So that's it. That's basically what this machine learning model is doing. And then we have our optimizer. Like I said, we have to just keep things simple. We have used Adam as our optimizer. And finally, loss function. Because we're dealing with a simple classification problem, and which means we have only 2 classes, we're using binary cross entropy as our loss function. But if you have something, if you want to do in future, if you want to do something like more than 2 classes, in that case, you can use categorical cross entropy, which means if you have um, more than 2 classes, you can use categorical cross entropy. And finally, for metrics. So for metrics, again, to keep simple things simple, we're using accuracy. So that's basically our model compilation and training. So as you can see here, the training starts off pretty good. Oh, thank God it didn't overfit. So as you can see, why I didn't want to show you guys training, because it's like 263 seconds for each and every epoch. So what is 263 seconds into 20? Can anyone answer me? Let's check it for ourselves, actually. I think it's better. So let's just try multiplying 263 into 20, which is like 5,260. So 5,260 seconds to hours. Let's see how many hours that is. So that's like 1.4 hours. So basically training this entire machine learning models, I mean, this entire network took me 1.6 hours. And obviously I can't waste you guys 1.6 hours of time here. So that's why I just kept it simple. So that's where it's already done. And finally, I saved my model. And now if we see the metrics of, let's say if you want to see the accuracy and the loss of our model right there, we can see the accuracy started from something like 0, and then it went to at least something like 0.99 or something like that. So it went near at least 0.98. And this is the actual training accuracy. But if you see validation accuracy, it went something very close to, like 0.98 or something like that. But we can perfectly say our model has a very good accuracy. That has no interaction. And finally, the how many what's the loss of the, if you want to see the loss right here, we can see it also had a very good loss as well, where it started from the certain degree and came down pretty efficiently as well, which means we had a good loss as well. And finally, on our testing data, again, we don't have so many images for training. So that's why we see for testing, we got an accuracy of 0.75, which trust me is a very good accuracy for what you've developed. Again, this accuracy can be improved, but it's going to need some bit more optimizations, and you have to use different types of layers as well here. But just to keep simple, I think 0.75 accuracy per test data is more than enough. And that's basically our neural network out there. So this is our complete neural network. So now let's try to develop this neural network in a web application. So that's the first part training has been completed. Now I'll show you guys on how exactly this is being implemented. So if you wanna detect the face and mask and everything, so I'll show you how you can implement this in a web application. So right now, like I said, we're using something called Streamlit. So Streamlit is basically this web application library. So this library can be used to create web applications. That's really what Streamlit is. We're importing TensorFlow and Keras, we're importing NumPy and all these simple libraries you already know. And the first things first, now we're loading our face detector model. Now remember, guys, we have previously saved our model, right? Did we save our model? Yes, so which means yes, so we have basically saved our model previously. So now we basically just give the different types of proto.txt part. Oh, sorry, yeah, we give the proto.txt part of our machine learning, our deep network, and the weights. So normally when we have trained this network, we have the certain weights which are saved. So it's also saved in a cafe model. So that's the weights which are saved here, and this is the rest than 310 SSD. So now we basically just, we just read the net, we give the pure text and pay part, and we return the neural network out there. And now we basically load our mask model. So our mask model again, we have already saved it, which is load model mask detector dot model, and we just return it. And now we come to the interesting part of detecting the mask. So to detect the mask right here, we first use the OpenCV library to read the image from the cache out there. So we first read the image from the cache, and now what we do, we basically use we use the CV2 OpenCV library to get our image and get it from BGR from from blue, green, red to RGB. So that's basically what we do here with the CV2 color. And then again, we basically just give it all the simple processing stuff like block frame and everything to give it a certain range from there. And now, and again, from this is also it goes into complication steps. But to be honest, what exactly was entirely happening from this point to this point, based on the confidence value we're giving, we're trying to create a B box. B box is basically it tries to detect the region of let's say the region of interest of our face title of the mask. So that's entirely what's happening out there. And finally, we basically tend to predict if the person is, if the label is something like mask, which means the person is wearing mask. I mean, it's based on the accuracy. If it's not wearing a mask, we're basically get a no mask. So that's exactly what we're doing. And finally, we're just putting some small text of the accuracy saying mask or no mask. And finally, a CVT to a rectangle. And this rectangle is supposed to mean our entire B box, the region of interest. So again, it's a bit too complex from this part, but in the most simple way, that's really what's happening. And then we also have an about page for our application where this contains a small about page of what exactly this application is about. That this project is for clever students by Siddharth Pilli. We explain the project right here. There's a small image of me, and we have a small caption. And finally, this is the entire application out there. Again, it's a very simple step 7. I'm not going to get too coherent on the code out there. What's entirely happening is that we're trying to just detect the face. We're trying to detect, the training part is done. We're trying to predict if the person is wearing a mask or not. And with that, we're also having a B box being performed in a face for the region of interest to just give the accuracy. And we just have a B box also for, at least detection part. So that's basically what this application is doing right now. Shall we run this application? All right, so we'll just run this application. So to run this application, I'll just share my command prompt there. So to basically run this application right now, what we have to do is we have to say Streamlit run mask detector. Oh yeah, I'm sorry, I think there's something wrong. Oh, I'm sorry about that. Yeah, sorry. So yeah, to basically run this mask detector, what we say is we can say Streamlit run mask detector and move the file. So now when I run this application right here, just give it a few seconds. It's going to just start the server. So it's going to need a few seconds, and there we go. So the server has started, which means we can basically start, in your application. So if we go to this local URL, it brings us to this website. So it's going to need few seconds to run. So just give it a few seconds. And I think it's going to be a few. Yeah, there we go. So now it'll basically start the face mask detector application. So as you can see, we have the face mask detector application. We have a small text about how it's developed. And now we can go to the about page to learn more about this project. So we can go to this about page. And this about page, it basically helps us understand this project for clever students by Siddharth Pilli. We explain what's happened here. And there's a small image from me and a small caption right there. And now if you go to the home page, let's actually try this application because we have developed it. So first things first, we have to drag and drop an image here, of course. So I already have a sample image of this person. We'll just drop it here. So here we can see this person is wearing a mask. So let's process that. And now when we basically run this program, this basically predicts that this person here is wearing a mask. So we can see we have this entire B box rectangle which contains if this person is wearing a mask. And here, so it's saying it's 99.994% sure that this person is wearing a mask. So there we go. Now let's say you want to predict if a person is not wearing a mask. So what can we do in that case? Let's browse more files. So I think I have a picture of me which I can share. Let me just share a picture of me. Pictures, just rough pictures out there. All right, I guess this is a better picture. Um, yeah. So even if this picture looks really bad, I'm so sorry for that picture. It's too embarrassing to even share it. But so let's say this is a sample picture out there. So now let's say if you want to predict if this person here, I'm not sure who is, if you want to predict if this person is wearing mask or not, I can just say process. And then it basically helps us understand that this person, we're 100% sure is not wearing a mask. So, the model has that certain range of accuracy that is very sure that this person is not wearing a mask. But there's a small problem. Now, the reason why I'm not wearing spectacles here is because we don't have too much data with contents of my spectacles. So that's the reason. So whenever I use my spectacles, it detects I'm actually wearing a mask. So that's a small problem. But if we get more data of people with spectacles wearing masks, we definitely need that. In that case, we can eliminate this problem. But that's the whole entirety of our face mask detecting project, where we can detect if a person is wearing a mask or not. So that's basically our project, everyone. I'll try. I mean, I have to still upload this to GitHub. I'm still trying to upload this to Heroku and everything. But once I upload this to GitHub and Heroku, I'll definitely give you guys the project, the code, and the entire website link as well. So you guys can try it on your own. And maybe if you want to try experimenting with this project, instead of using mobile net V2, there are a bazillion number of architectures out there. You can try using a RESTnet architecture, try using Inception, try using Exception. So try using different types of algorithms to predict if a person is wearing mask or not. And there are also different types of data sets available as well. So try exploring the internet, try collecting more images of people with masks and people not wearing masks, and try to include that in your data set as well to get better accuracy and to not lead into overfitting as well. But that's basically what we have for today's session on a complete introduction about myself and on how you can, about my journey on why you should be a data scientist, and a complete short form tutorial on how you can develop your very own face mask detection application. I'll share the code, the GitHub link, the server access as well. And just once the posting has been completed. But that's basically for today's masterclass, everyone. I'll just give it across to Samveen. Um, Hello, Samveen. Um, just a second, everyone. I guess I don't think submarine is just. Oh, okay. So in the meantime, everyone, I mean, hopefully, what you can try doing is now the reason actually I want in the starting I wanted to implement this webcam feature where you can actually directly see the webcam and detect as well. But there was a small problem with Streamlit, but Streamlit really does not accept this whole webcam thing. So that's why I didn't get that. I think Sunreen is back, so I'll just forward it to her.
Yes, Siddharth, thank you so much for such an informative webinar. And students, I hope you all also enjoyed it. Is it?
Can I ask a question?
Yes, tell me.
No. To him.
Yes, okay, Siddharth, you have a question. Yes, sir.
All right. Yeah, please go ahead.
Can it actually work with other masks? Like those masks with like decorations? Can it also detect those masks?
I'm sorry, I didn't get that.
Maybe
The mask,
you can just write your query on the chat so that Siddharth can read it out and help you out.
I can't. It says it's the same one.
It's disabled. Let me enable it for you once again. Just give me 1 second, okay? I think now you can write it.
The masks that have decorations. I mean, yes, definitely. There'll be any mask out there. You can definitely it can try it out there. Right, the masks that have decorations, right? So let's say your mask has this above like designs out there, it can detect that. I mean, it's only kind of find the features on what's covering your face at what point and the color, and these different types of features are actually what I try to understand on if there's a mask or not. So yeah, so for example, even if the mask has decorations, it's still going to be counted as a feature, and the model can still detect that. Can you try testing the picture with the mask below the chin? I'm pretty sure it's still going to detect there is a mask because I didn't. There's not. There, I didn't. I don't really have a data set which can understand if the mask is worn incorrectly. If it sees a mask, I'm pretty sure it's going to identify that it detects a mask as well. So yes, even a homemade mask is going to detect that.
But does it have some problems like something's not one?
No, I don't think so. I mean, it's always about what the model is learning because when we have thousands of images to learn from, it's obvious that it's going to figure out some feature out there which can understand, even if the mask has the decorations that, it's still detectable. So it's going to sort of find that feature into it.
Or can it be like web? Can it be web?
I'm sorry.
So one question was, Siddharth, why didn't you use a web light cam? Why did you upload a picture of yours?
Yes. So what exactly happened was Streamlit is, pretty much it's a beginner library because Streamlit has been recently developed, and I mean I've been literally looking hours and hours, and I couldn't find a webcam library which was something safe and something which was in Streamlit. So I didn't find that, and the only way I guess which can be done was something using like an external API out there to get the webcam software. And that doesn't seem like a right solution because it's again it makes things even more complicated, and I was even scared about the security as well. So that's why I thought uploading images is better than using some deprecated library which provides the webcam. So that's the reason I haven't used the webcam, but I probably should have tried to figure out a way. But it's at least a reasonable outcome for your opinion. No, I mean, analyzing live, it's definitely not going to be harder because we're just going to capture a frame out of it. So it's definitely not any more harder than you think.
And one question was, I think, that if you give just mask and no person, then what will happen?
If you just keep a mask and no person, now that's an interesting thing out there. So, I mean, I
I'm
haven't
pretty
tried
sure you
it, but
already mentioned that.
oh, I mean, wait, I mean, I guess I specified. I guess, I mean, the sorry, what AI tries to do is it tries to understand if there is a let's say person, and then we try to figure out if he's wearing a mask or not. And if I'm pretty sure it's something between a 50-50 outcome. I mean, I'm not sure this is something which can be taken into an
Yeah, because
experiment,
of the
but
B box.
yes, the B box. I mean, but B box requires a region of interest out there. But I mean, I'm not completely sure what the outcome is, but there's a 50-50 confidence level that it might predict that there is no mask, or it might predict that there is mask. So that really depends because a mask is only worn if there's a person wearing it, but if there's not, it's a 50-50.
Yes, and also the B box is going to be janky because it can't analyze like, oh, whether there's a face or not. So it's not
No,
able to find that
exactly,
point of interest, and that is what will create the 50-50, correct?
exactly, yes, exactly.
Any other questions,
Can it
students?
be flip? Can it be like flip? What happened?
Can it be tricked,
What?
Siddharth? Can you trick the face mask
Like,
detector that you
what
made?
happened? What if I
I'm
like
sorry.
use a tissue, like a tissue, and then come on my mouth? Can it be like flip or something?
So Siddharth, Sam is asking, can you trick your face mask detector?
No,
Instead of mask, if
Do you
it's
see
something
a
else.
paper? Do you see this
Um,
tissue? Can you see this
Well, I
tissue?
think actually I've seen these cool things like a transparent face mask where your entire face is visible through the mask as well. So I guess it's a transparent face mask. I'm pretty sure if you use something like a transparent face mask, it can definitely detect that you're not really wearing a mask. So that's one way.
Yeah,
But I
because
guess
it's
if
going to
you
notice the
have
mouth rather than a covering.
exactly. But I believe that if we do get more data for transparent masks, and I don't think we can detect that as well. But it's all about how much
Yeah, if you
data.
put a couple
And
of pictures of somebody wearing a paper towel on their face, it's going to detect the whole mask covering thing.
yes, of course. And even if it's let's say a person just wearing a cloth mask or something like a cloth, yeah, just cloth tied to his head around, it's not even. And if it's included in a trainable data set, it's going to detect that as a mask as well. But we don't want that to happen because we want to have everyone to wear a safe and unofficial mask. So we don't want to have we don't want that to happen. So I think it's better that we're just wearing a good and a normal mask as well. I think it's better than that case. But yes, you can definitely predict if you have data samples for cloth, you can predict if a person is wearing a mask or not, if even if it's a cloth. On which platforms are we making the mask data actually? Well, we're basically using Python as our base programming language. We are using a Streamlit, a web application, a framework to develop our mask application. Oh, and we're using different types of deep learning libraries like TensorFlow, Keras, and an image processing library called OpenCV. I believe it's Open Computer Vision. So these are the platforms which we're using to develop the mask detector. How does the ML actually learn? So ML tries to learn based on the data. I mean, actually, ML is different from deep learning. So ML basically tries to learn, to just try understanding the data. It tries to find patterns, and that's really how machine learning tries to learn. But for deep learning, it tries to find all these features and all these patterns and everything. So there's a certain difference between what machine learning does. For machine learning, you need like this complete type of organized type of data set for each and every part. But for deep learning, it's not really that necessary because deep learning figures out its own features in there. For example, let's say you have to predict Boston's house pricing. For Boston's house pricing, you have all the features, like it's all labeled up to you, like the price of the house, let's say the square feet, and etc. etc. So machine learning already uses features, finds the patterns, and learn. But for deep learning, let's say if you're asked to predict the Boston house pricing, where where it basically has all the different types of pricing, it has all these different types of features. Deep learning tries to experiment, tries to have these different types of outcomes coming again and again until it gets this good accuracy. It tries to understand these patterns and then tries to use the right features to predict, the Boston's house pricing. So that's really the difference between how deep learning learns and how machine learning learns.
I have a question.
Yes, go ahead.
Okay. When we if someone printed his mouth and nose in a cloth and made a mask with that and wear it, and he goes to the and he upload his picture on that mask detector. So what will it say?
So I'm pretty sure I guess it's going to say that it has no mask because if it's, let's say,
Yeah.
if it's very similar, if it's very accurate, let's say the face color, see everything out there, it might probably detect the person is not wearing a mask. But there is a certain, let's say, some noise or something like that, it may detect that the person is wearing a mask. So there's a 50-50. It all depends on the sample of data out there. So a person is saying it definitely seems that data is what makes more accurate, and true, it does, because the more data which we have, the better the model which we can learn. And deep learning is completely is inspired from the human brain working. For example,
Oh
if
yes.
we as a person, if we see more images of a cat, or if we see more images, so if we see a real life of a cat and different types of cats as well, we can understand that this animal here is a cat. How do we know that? Because
Okay.
we've seen it many times. So something like that.
Okay. Yes.
Can you also
All right. Just maybe one or two questions more, and then we need to end this session. Okay.
Sure.
Just one question more, just one last question. Maybe you all can write the question and Siddharth can just select one question and give the answer. Okay, just one
Teacher,
last
my
question.
question to you. Teacher, I'm asking, should
Students
you
on
fill the
chat,
form now?
on the chat, yes, you can fill the form. And if there's any question, you can just write one last question and that's
Last question. What if someone covers
Okay,
their
teacher.
mouth with a
I'm filling
hand?
the form.
So if a person really covers, again, it really depends on the data as well. If for example, the data, if you look, let's say, if the person covers a mask, so there are samples of people covering with hands with their mask, as if it's objectified as an image, and if it's actually in the training set, which with the label of mask. So there's a probability that this is going to be considered as mask. But if not, if for example, if the AI does not find the right feature, it to be considered. So again, I can't really, because I don't know what AI is thinking, because deep learning is a complete black box. That's its own feature, and it tries to find its own pattern and features to understand if a person is wearing mask or not. So I can't really go inside the network and understand how is it understanding, because it's all mathematics and etc. So I can't really understand that. But it's because, for example, let's say if a person, what's a good example? I'm trying to think of a good example. All right, good. So, for example, let's say if you have a person who is, let's say, in Mumbai. So, if you go to a person to Mumbai, and if we tell the Mumbai person to, like, if we ask him, if we show him a picture of pav bhaji, if you ask him, how do you know that this is a pav bhaji? Now, his experience might be different, right? Maybe he had this, maybe he's pav bhaji a lot. He knows the right bread, the right curry, and right everything. So, because he has more access to pav bhaji and everything. So because we can't really go to his mind and understand that, hey, how do you know that this is a pav bhaji? But we can include similar maybe features, like if the bread, if it has two layers, if the curry is like red, it has onions, it has butter, and all these different types of features, we can identify that this is a pav bhaji. But to be very accurate that this is a pav bhaji, we need more data for it. And maybe the person in Mumbai, he knows that this is a pav bhaji based on his experiences with it. So we can't really go inside a person like a neural network to identify how does this person know that this is a pav bhaji. But what we can do is, through simple features, we can at least identify ourselves that, okay, so this is a pav bhaji. So it's something more related to that concept.
all right. Thank you so much, Siddharth, for your
I
valuable
still
time.
have one more question.
No, that's it, students. Siddharth needs to leave now because he has some prior commitments. So thank you so much, Siddharth, for valuable time.
Thank
And it
you.
was a
Thank you.
really fun session. And thank you so
Thank
much
you.
for clearing the doubts of all the students.
Thank
I
you.
hope you all enjoyed, right, students? Can we have a clap or something? Can I get a reaction from all of you? Did you like the student? Did you like the session? Awesome, great, awesome.
Thank you, everyone.
So
Thank
please
you.
don't forget to fill the feedback form, and let us end the session. And bye, everyone. Take care, and thank you so much again, Siddharth. Bye, bye.
Bye, everyone. Thank you so much. Have a great day. Thank you so much for having me here.
1 minute, teacher. I didn't fill the feedback.
Siddharth, if you want, you can just leave the session. Thank you so much.
All right. Thank you.
Okay, students. Meanwhile, you can just open the form link, okay, and please fill it, and then you all can leave the session.
Ma'am,
He's
where
done
will
what?
we get this recording?
So anyway, the
finished
session was
filling it.
live on
I'm going.
YouTube. So you can just subscribe to our YouTube channel. The link is there on the chat. And you can always go back and see the recording, see the video. We all were live on YouTube. So you can just go over there and go to the live stream.
What about the link to the project?
The link of the project. Okay, I'll ask Sulagna ma'am if that
Yes,
can
I
be
finished filling it.
If you're done
Ma'am,
with
I
your
also completed filling that.
Thank you,
Okay.
ma'am.
Thank you so much, student. Thank you so much for joining today.
Bye, ma'am.
Bye. Take care.
Bye.
1 minute.
Okay. See, students, even if you have opened the form, you can just fill it and then submit it. Okay. It's fine. Just open it, open the link so that we can just end the session and you can fill it meanwhile. Okay. Just open the link, student, so that we can end the session.
I've already opened the link.
You have opened the link, no? If the link is open, it's fine. Please, meanwhile, just submit it. Meanwhile, we can end the session. Just please confirm if everyone has at least opened the link.
Yes.
Yes, Nadeem, Samriddhi, Harish.
Please, I'm leaving the meeting. I have opened the form.
Okay, Naina, bye. Okay, everyone, let me just end the session now. Bye, everyone. Take care. It was a fun session today. Bye-bye.
Bye-bye, Visha.